Okay, in this video I'm going to be demonstrating the IV or current voltage curve for a green LED, and we'll be using that information plus information from the other LEDs to calculate Planck's constant, hopefully. So here's the setup. There's a green LED here, and in series with it is a 100 ohm resistor. The purpose of that resistor is not to limit current, it's to measure the voltage across it, send it to the picolog, and inside the picolog change that through Ohm's law to a current and record it. And we also have differential channels set up to measure the voltage across the LED. So channels 1 and 2 are differential voltage for the LED. Channel 3 and 4 are the voltage across the resistor, which is then converted to a current. And the power for the circuit is being supplied by this power supply over here. Because there's a 100 ohm resistor in series here, the voltages on this are not going to be accurate for the LED, and the current isn't that accurate. So I've set up two digital multimeters. One here in the back is measuring the voltage across the LED, and it's showing 1.49 right now volts. And this particular multimeter is showing the current in microamps, and it's giving us a value of about 4 microamps. Now again, all the data is being sent to the picolog as well to record, and the picolog also can be displayed on the personal computer, of course. So my laptop is here, and up at the top in brown, and we'll see it also in brown when we get to the graph in a minute, is a differential across 1 and 2, which is the LED forward voltage, and it's showing 1.5 volts right now. And differentials 3 and 4 are across the resistor we use to measure the current. And there is a difference here between the two, this multimeter and the picolog. Picolog shows about 2.5 microamps. I believe it to be a little more accurate. I've also set up a calculation here to display scaled such that we'll be able to see it in the graphical mode in a minute. So just real quickly, let me get it started recording data. And we will switch it over to graph mode. Here's the graph mode, and just to recap again, the brown line, 1.5 volts, that's the voltage across the LED, same voltage that we see on this multimeter. And down here, the kind of a scaled value for the current in blue, and the green is just the raw voltage across the resistor. But I can also read the microamps up here. So what I'm going to do though is use these two multimeters to read out values as I bump up the power supply over here, but the more accurate values will be inside the picolog. Okay, let's get started. And my power supply goes up in increments of 10 millivolts. So you can see up here on the brown line, it's starting to climb, and we're at 1.6 millivolts. But notice that the blue current line isn't doing much yet. So 1.7. 1.75, maybe a little movement down here on the blue line. 1.8. 1.85 volts. And there's been some increase on the blue line down here. And remember that 1.85 volts is where I believe I can see some light coming from this green LED. So we'll keep going from here. And pretty soon we'll see the blue line start to really climb. We're at 1.95 volts now, and you see it climbing. 2 volts. Current's at over 6 microamps. 2.1 volts, and look how the current has climbed to about 27, or showing here 30 microamps. And I'll keep going. I can see the LED pretty clearly now. I'll keep bumping it up though so that it's clearly visible on the camera. And now we're at 2.2 volts. 2.2 volts and 243 microamps. That's a demonstration. Hope you enjoyed it. We'll be doing this for the red, blue, yellow, and orange LEDs, and then I'll use the tabular data here and export that as a CSV file so I can analyze it further in Excel. And that's it. Hopefully we'll be able to calculate Planck's constant.